Welcome to Study Loop.
Hi. First of all, we will draw the given curve of magnetic field with the passage of time, after which we will convert this curve into a curve for EMF induced with the passage of time. Here, in this given curve, the magnetic field is varying along y-axis and the time is varying along this x-axis. Now, we will extend the curve to include a curve between, we will extend the axis to include the curve for magnetic flux and hence the EMF induced with the passage of time, like this. Now, first of all, the given curve is plotted at the times t1, t2 and t3 as given here. This is t1, this is t2 and here this is t3. So we will combine these times at both the axes like this. And one more for T3. So these are the reference lines for time. Now, the curve given for the magnetic field is varying initially from 0 to T1. It is increasing with the passage of time. Then it becomes constant for the duration of time from T1 to T2. And after that, it falls down sharply from T2 to T3. Similar will be the behavior for the magnetic flux. As we know, the magnetic flux is given as the product of magnetic field with the area, and as the area will remain constant, so the flux will also be showing the same behavior. Now, in the second curve, we have to show a relation between induced EMF and the time. So, according to Faraday's laws of electromagnetic induction, induced EMF is given as the negative of the time rate of change of magnetic flux, or we can say this is the negative of the time rate of change of B multiplied by A. So, as the area will remain constant, so this is negative of 8 times of dB by dt, and dB by dt is nothing but the slope of the curve. So the slope is represented by the gradient of the magnetic field. Hence, in the first part from this origin to T1, as the slope is increasing, so the EMF will be having a negative value because of this negative sign, and it will be constant because the slope is constant. So the value of this EMF induced will be like this. This is, suppose, the value of the EMF induced. Now, during the time duration from T1 to T2, as the magnetic field becomes constant, so the flux will become constant, means the dB by dt means the rate of change of magnetic field is constant, means the slope is constant. So now in the duration from T1 to T2, EMF will be 0. No EMF will be induced as magnetic field is constant, and the differentiation of constant comes out to be 0. So Now the EMF induced will be 0 from the duration from T1 to T2. Finally, for the time duration of T2 to T3, the flux is reducing, the magnetic field is reducing, so the magnetic flux will also be reducing. So the EMF induced will become negative of area multiplied by the slope, and the slope is negative. So overall EMF induced will be positive, and as the slope is having a larger value as compared with this first slope, so the value of EMF induced will be more than that of the value E1. So now the EMF induced will be represented like a bigger pulse, like this. So this is the graphical representation of EMF induced with the passage of time corresponding to the variation of magnetic field with the passage of time. Thank you.